Hello friends, I am Professor Thakur welcomes you on my YouTube channel for this subject head digital communication. Friends, as far as our today's session is concerned, so we will try to learn the two important functions of this term that can be called it is as a random variable. And these two important functions of this random variables are nothing but, as you can see, mean and correlation. So let us quickly start our today's session with this first very important function of this random variable, whose name is nothing but the mean value, or we can call it as a average value, or it is denoted with this alphabet, call it as a E. So that can be called it as a expected value. So mathematically, first of all, we need to understand the basic definition of this mean value of that random variable. So as you can see here, the term is written in this way, E of x, where x is nothing but what? The random variable, and we are interested to define the mean value of this random variable, right? Now, as we are very much aware of this thing, there are two types of random variable, right? The first random variable is nothing but what? The continuous type of random variable, and the second one is nothing but what? The discrete type of random variable. Based upon these two types, mathematically, as you can see, there are two different types of operators. The first one is nothing but what? The summation sign, and the second one is nothing but what? In which, or in that definition, we used to have the integral sign, right? So in this summation sign, so as you can see, this I is being iterated from 1 to n, means n number of samples we can have with us, means summation sign it is related to the discrete type of random variable, right? And this integration sign means what? That mean value is related to the continuous type of random variable, which is uniformly distributed from minus infinity to plus infinity, right? As far as the upper and lower limits of this integral signs are being considered, which denotes the distribution area of that particular continuous random variable. So in this way, basically, the mean value is to be defined of that discrete type of random variable or the continuous type of random variable. If it is the discrete random variable, so its mean value or the expected value or the average value is nothing but summation of I equals to 1 to n followed by xi into pi, where p is nothing but what? The occurrence probability of that random variable. How many random variables we can have with us? Starting from 1 to n, right? Similarly, when we are having the continuous type of random variable, so in that continuous type of random variable, in its mean value or into the definition of its average value, this probability density function is being used, which is denoted by this term f of x into ds. So which will try to tell us the density of that probability belongs to this random variable, which is being uniformly distributed from minus infinity to plus infinity. So this is how the mean value of that random variable is being defined, right? So after going through the mean value of this random variable, the second important function of that random variable is nothing but what? As you can see, the correlation, right? So first of all, we need to understand what do you mean by this correlation. So the answer is very simple. This correlation will try to tell us the degree of dependence in between any two random variable, right? Or we can say that it is the strategy by which we can analyze the relation in between any two random variable. That is nothing but what? The correlation. So generally this correlation is defined with the help of this another function as far as this random variable theory is concerned. As we know, it is nothing but what? The technique by which we can understand the desired relationship in between any two random variables. So let us consider these two random variables apart from its type, whether it is continuous or discrete. When it is required for we people to define the correlation in between these two random variables, so this correlation is denoted with the help of this another function, that is nothing but what? The covariance. So ultimately this covariance of x and y, means it will try to tell us the degree of dependence in between x and y. So this covariance function is to be defined with the help of this expected value, or with the help of this mean value operator denoted by this capital E, right? So as you can see in this two curly braces, how that covariance function is to be defined in between these random variables x and y. It exactly equals to E of, within this first parenthesis, x minus mx, within this second parenthesis y minus my. Now what this mx and my stands for, as we are defining the expected value. So mx is nothing but what, the mean value of this random variable x, and my is nothing but the mean value of this random variable that can be called as a y, right? Then furtherly certain mathematical simplifications are there. So when we multiply these two parentheses with each other, so as a result of multiplication, as you can see, it will become x into y. This x is being multiplied with this term, so it will become minus of minus of mix. Similarly, this mx is being multiplied with this y, so it will become minus of mx into y, right? So the remaining term is nothing but what, mx into my. So by doing this simple multiplication, what we need to do, we need to define the overall covariance function. Okay friends, so after going through this mathematical simplification, once we try to expand this parenthesis by means of term by term multiplication, and one more thing that we need to understand, as this E stands for what, the expected value or the expected operator, because basically it is a linear function, so it will get multiplied with each and every term belongs to this term by term multiplication. So as a result of doing this, it will become E of xy, it will get multiplied with this each and every term, right? E of xy minus this my is nothing but what, the constant term, so that's why it is being kept outside this expected value operator. So my into e of x. Similarly again mx is a constant term, so mx into e of y, plus the remaining term is nothing but what, my into mx, right? So we can change its order, so that can be rewritten as mx into my. Now after that, we are very much aware of this thing, this e of x is nothing but what, the expected value of this random variable capital X denoted by mx, and e of y is nothing but what, the expected value of this random variable y, generally denoted by this relevant expression my, right? So when we substitute these two relevant expression into that above expression denoted by this star sign, so it will become what, e of xy minus my into mx, because e of x is nothing but what, mx, minus my into mx, because my is nothing but what, e of y, the expected value of this random variable y, so my into mx, remaining term as it is. Furtherly, when we simplify this existing term in terms of this subtraction, so it will become what, e of xy into minus minus, these two terms are being combined, so it will become minus 2 into mx into my plus mx into my, right? And see, here we used to have the negative sign and the positive sign, as these two terms are quite identical to each other. So after going through this subtraction operation, it will become, or the overall function of this covariance term, it will become covariance of x comma y equals to e of xy minus mx into my as a result of subtraction. So this will try to tell us how this random variable x depends upon random variable y in terms of their mean value denoted by e of xy minus mx into my. So this is the generalized definition of this correlation function when we are dealing with these two random variables x and y. But in practical scenario, in case of this digital communication, as we are in need of multiple number of random variables, right? So when it is required for we people to handle n number of random variables, so at that time what we need to do, in order to define the correlation function, so this term is being taken into account, that is nothing but what? The correlation coefficient, right? Denoted by the sigma xy upon sigma x into sigma y, where this sigma denotes the correlation of this x with respect to y, and this sigma x as far as its denominator is concerned. So these two terms are nothing but what? The autocorrelation functions belongs to x and y. So probably in forthcoming lecture, in detail we will try to learn this autocorrelation function, because basically in case of this discrete time, autocorrelation is nothing but what? According to its definition, we too can define like this: covariance of x into x equals to E of x minus mx into x minus mx, means it will try to deal with that its delayed sequence, right? That is nothing but what? The autocorrelation function. So in this lecture, I just hope we have gone through the introductory part of this mean value as well as the correlation function of this random variable. So I just hope you had understand all those things belongs to these two functions, right? Thank you.